Hi all, I'm Madam Kong. Welcome to my virtual class. The purpose of this video is to revise Organic Chemistry SK025 by using set PSPM 2018-2019. Okay, this is the latest format. This is the latest format, and then the paper 1, 29/40 question, and then for paper 2 is 6. Compound A is a 4-membered ring alkane, so it's cyclobutane with molecular formula C5H10, meaning that there is another one carbon as the branch. So draw the structural formula for all possible mono-substituted product, meaning that this is the only place that the chlorine can be substituted for the reaction between C5H10 and chlorine in the presence of UV. Okay, light is UV. So I can put over here as the tertiary alkane. I can put over here the C2, here is C1, so say C2 as secondary haloalkane. Here is C3 as the secondary haloalkane as well. I also can put over here the branch, okay, as the primary haloalkane. Why I can't put at the C over here? The chlorine put over here, actually if I put over here, right, it's same as this one. So that's why total there are 4 possible mono-substituted product. Okay, next we proceed for the part B. Write the reaction mechanism for the formation of the most stable reaction intermediate for A. If I want to form the most stable reaction intermediate, I have to choose the most stable haloalkane, which is tertiary haloalkane. So mechanism, so half arrow. Okay, so point to here, we'll form the free radical over here. Here, form the H dot free radical, join with the Cl dot free radical, and then form the HCl. So this is the most stable carbocation. Okay, so this is the original question from question 5 from benzene and alkene. This is alkene, this is benzene. First, name compound B and C according to IUPAC nomenclature. So B is this cyclohexane at the position number 1, so 1-methyl cyclohexane. So for benzene, so this one is a methyl, so methyl benzene. For your information, if the benzene compound with, if the substituent at the benzene compound for the position number 1, we no need to put 1. So for example, nitrobenzene, bromobenzene, chlorobenzene. So the best answer is methyl benzene. Okay, B. Both B and C can undergo oxidation reaction with the same oxidizing agent. We try to use the most common one, KMnO4. Write chemical equation involved and explain the difference between these two reactions. So this is the first equation when 1-methyl cyclohexane react with the oxidizing agent. I encourage my student to write this one because this one easier. KMnO4, H plus heat. Okay, look at here. When alkene react with oxidizing agent, so you break the bond over here. Okay, bond breaking over here, and then here will form double bond O, double bond O. You check, is there any hydrogen over here? Yes. This one will continue become carboxylic acid. So that's why this area is COOH. Another area is C double bond O, CH3, and then CH2, 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 CH2. So for compound B undergo reaction of oxidative cleavage, which is breaking of carbon-carbon double bond. For methylbenzene, it will undergo oxidation from benzoic acid. So this is oxidation reaction. Okay, C. Name one reaction that convert B to methyl cyclohexane. So this is B. Okay, become this. So automatically we'll know this is halogenation. Is it? Halogenation. Sorry, not halogenation. It's hydrogenation because it's H2 added. Okay, why we cannot write down electrophilic addition? Because electrophilic addition is the type of reaction. But here is name one reaction. Not asking about type of reaction, just one reaction. So it's hydrogenation. Okay, let's discuss question 6. Two organic compound D and F with molecular formula C4H9Br. So mean that D and F are haloalkane. React with suitable reagents to form E and G. So where SN1. So SN1 and SN2 respectively. So D form E SN1. So this information we know SN1 is preferred tertiary haloalkene and react with weak nucleophile. The nucleophile is identified because we check B suggests reagent for the formation of E and G. Okay, and then F, G, SN2 with green color. So SN2 prefer primary haloalkene, so it's use strong nucleophile. Then both E and G have a molecular formula of C4H10O. Based on this general formula, right, we can deduce actually this is alcohol. So now I have to draw the structural formula for DEFG and then state the reagent, suggest the reagent for E and G, and then write the mechanism for the formation of E. E most popularly is a tertiary haloalkene. Okay, yes, T is tertiary haloalkene. So tertiary haloalkene, then it will form E. E is a tertiary alcohol. We check the number of C, 1, 2, 3, 4, number of H, 10, and then O, tally with this molecular formula. And then F is a primary haloalkene. There are two possibilities. Either is 2-methyl, 1-bromopropane, or 1-bromobutane. So if using this answer, then this alcohol will be formed. If using this answer, this alcohol will be formed. So suggest reagent ESN1 using weak nucleophile. So the answer is water. SN2 undergo the backside attack. So we are using the strong nucleophile, which is sodium hydroxide or potassium hydroxide. Okay, next C. Write the mechanism for the formation of E. E is a tertiary haloalkene, so it will undergo SN1. Unimolecular nucleophilic substitution. I encourage you all write the name for step 1 and step 2. So for here, step 1 is formation of carbocation, and then please state the class of carbocation, tertiary carbocation. So for this one, it's a rate determining step, it's a slow step and reversible arrow. So tertiary carbocation is formed due to the hydrolytic cleavage of the CBr bond. Next, second step, attacking of nucleophile. So it's a fast step. So the weak nucleophile, we are using water, attack the carbocation to form a product of alcohol. So it will form the protonated alcohol, then the H2O regain the acid, okay, and then form the alcohol and H3O plus. Also is a fast step. Okay, the structure formula of compound H is shown below. So let's check for the number of carbon. C1, C2, C3, C4, C5, C6, C7. Heptanol. Okay, alcohol is at the position number 3, so it's 3-heptanol. Okay, name functional group of compound H, no problem, simple question. Suggest a synthetic pathway to prepare H, where green light reagent and propana. Okay, propana is a 3-carbon compound. So compound H is a 7-carbon compound, meaning that, okay, another reagent that react with propana is a 4-carbon compound. So if I want to form alcohol, react with propana, it will form a secondary alcohol. So this is an haloalkene. Okay, compound H react with J. Okay, alcohol react with J, form, okay, double bond O2. Okay, the easiest thing for our double bond O is ester. Another hint is here, few drop of sulfuric acid is used. So J is a carboxylic acid. Because alcohol react with carboxylic acid, then only can form ester. So esterification. Since H already 7 carbons, here C10, so meaning that J is a 3-carbon compound. So yeah, simple, propanol acid. Let's check the answer. Yeah, the answer for the A is hydroxyl group. Okay, this is an assay, 4-carbon compound. So we are using 1-bromobutane react with the green light reagent Mg, and then form the green light reagent. Make sure you write down the solvent, dry ether. So this green light reagent, we straight away use 1 Roman propana, 2 Roman H3O plus hydrolysis, and then form the compound H. Okay, compound H react with propanol acid. J is a propanol acid. Okay, in the presence of sulfuric acid. So strong concentrated H2SO4. So function of sulfuric acid as a catalyst. Okay, next. Question A. I always say, right, this kind of question is question simple question. Okay, arrange the following compound in ascending order. Ascending order means 1, 2, 3. In order of boiling point means from the lowest one until the highest. And you have to know how to explain your answer. This is aldehyde, is it? C double bond OH, yes. Carboxylic acid, this one is alcohol. Based on the following reaction scheme, draw structural PT and give the reagent QRS. Let's check the answer. So answer for the arrangement start from L. L is the lowest one. Butana followed by N butanol, and then butanol acid has the highest boiling point. So L, M, N, ascending order of boiling point. M butanol acid has the highest boiling point because it can form hydrogen bonded dimer. Followed by N, N can form hydrogen bond. Okay, and then L actually cannot form hydrogen bond, but L is a polar compound, so it forms dipole-dipole interaction. So dipole-dipole interaction is weaker than hydrogen bond. So this is the answer given by the book, but I prefer you all write like this. M and N can form hydrogen bond, so N can form hydrogen bonded dimer, which has a stronger hydrogen bond compared to N. And then L cannot form hydrogen bond; it only can form the it's a polar compound. It forms the dipole-dipole interaction. So that hydrogen bond is stronger than the dipole-dipole interaction. Or we say hydrogen bond is stronger than the van der Waals force bracket dipole-dipole interaction. Okay. Based on the following reaction scheme, draw. Okay, first this is ozonolysis. Okay, P is a alkene, and then form only one compound, meaning that P is a symmetrical alkene. So here is butana, so another butana, then 8 carbon compound. So this is the answer. CH3, CH2, CH2, CH, double bond, CH2, CH2, CH3. You break and then form two same compound, which is butana. Okay, Q. Okay, from aldehyde become alcohol means undergo reduction. So this is the answer. I encourage you to write down 1 Roman LiAlH4, 2 Roman H3O+. Okay, and then R is oxidation. So we are using the strong oxidizing agent. Okay, this is a complicated way to write out the oxidation reagent. I prefer you write out the simplest one. If you want to write down this, please remember must write down 1 Roman K-metal-4, hydroxide, heat, and then 2 Roman H3O+. Must take 1 Roman, 2 Roman if you write down this answer. If you don't want to write down the complicated one, you just simple K-metal-4, H plus heat, either one. Yeah. You also can use potassium dichromate as well. Okay, S. Initially here is 4 carbon compound and then suddenly become 5 carbon compound, meaning that 1 carbon is added. So here I use Grignard reagent. Okay, so 1 Roman Grignard reagent, 2 Roman acidified H2O+. Okay, next is about condensation. So it will form the C double bond N, and then the H2O will be eliminated. So the NOH remains. So the H2 is taken, and then the O is taken from the H2O, and then C double bond attached with the N. Initially C double bond O, and then now attached with C double bond N. So the H2 over here, okay, will join with the O here from the H2O. So this is a D. Here you just copy CH3, CH2, CH2C. Everything is the same. And then the H still the same. And then the double bond O change to double bond N. So N still attached with the OH, and then the H2 over here, and then the O over here is eliminated. Okay. This is question 9. Let's check the question analysis and answer for question 9. Okay, treatment of 2-phenylethanol acid with alcohol. The reaction between carboxylic acid and alcohol is esterification, so we'll get an ester. Ester V with molecular formula of C11. Okay, C11. Initially here is 2-phenylethanol. Phenyl is benzene ring, already 6, 7, 8 carbon. So here another 3 carbon compound. Okay, so U is a 3 carbon alcohol. Alcohol U react with an alkali iodine solution to form a yellow precipitate. So for this alcohol, there is a methyl carbonyl group because it gives the positive test towards the iodoform test. And then whereas oxidation of U yield X. Okay, so this is the answer for UVX. Let's check. Is there any methyl carbonyl? Yes, methyl carbonyl is over here, and then it's a 3 carbon alcohol. Phenylethanol acid over here, the OH, and then attached with here. Okay, so this is the ester compound B. And then U undergo oxidation, so ketone, so propanol is produced. Number 2, write all chemical equation involved. So this is the esterification. Remember, must use the concentrated H2SO4. So the OH is eliminated, join with the H from the alcohol. So, and then form the ester, C double bond O, COC, the byproduct is H2O. So the blue color, okay, H2O. And then this is methyl carbonyl group, right, with iodine /OH negative, and then form the CH3, C double bond O, O negative. And then the CH over here will form the iodoform. This is the yellow precipitate part. Okay, and then oxidation again. Okay, I will encourage you all use the simple version. So and then form ketone. Give the IUPAC name of W. So what is W? Yellow precipitate. Form a yellow precipitate. W is referred to this one. So this is triiodormethane. So this one is triiodormethane. Okay, B. Explain why methanol acid give a positive test towards tolerant reagent, but ethanol acid does not. You have to explain and then write the equation. So methanol acid is special because it have the C double bond OH group, which is the aldehyde group. So the methanol acid can be oxidized or can be reduced. Has the reducing properties. Can be oxidized or have the reducing properties. So you check here. This part is the aldehyde properties. Here, right, with the tolerant reagent. Okay, and form CO2, H2O, and the silver mirror. This is question 10. Okay, let's discuss and analyze the question 10. The reaction scheme below show the formation of a di-DD from benzene. Okay, so it started from a benzene and then from nitro compound. So this is actually is nitration in benzene topic. So the reagent is concentrated H2SO4, concentrated nitric acid at 50 to 55 degrees Celsius for reagent AA. And then zinc H+ actually is the reagent for reduction of nitro compound. So once the nitro compound is reduced, it will become aniline. So aniline react with CC and then form this compound. This is benzene diazonium salt. So it happens when aniline react with nitrous acid test. So what is the reagent for nitrous acid test? NaNO2 HCl at 0 to 5 degrees Celsius. And then the last one is the benzene diazonium salt react with phenol. So this is di. So the name of the reaction for the formation of DD di is coupling reaction. For part B, N-methyl amphetamine is a potent central nervous system stimulator. Okay, the structure. Okay, the important point from here, N-methyl amphetamine. So you check, attached to 2 alkyl groups, so it's a secondary amine. Now the question 1, name a chemical test to distinguish between this compound from aniline. Okay, you try to draw the structure for aniline. Okay, so this is structure for aniline. So aniline actually is a primary amine. So this is a secondary amine. We can test them by using Hilbert's test, nitrous acid test, and aniline is special. Actually, aniline also from something like phenol, so we can use the bromine aqueous solution. So there are 3 chemical tests can different these 2 compounds. So let's start with Hilbert's test. So for primary amine aniline, okay, react with the, what's the name of this one? Benzene sulfonyl chloride in potassium hydroxide. So this clear solution will be formed, and then followed by adding acid, and then clear solution will form. So this is for primary, this is the observation for primary amine. So addition of benzene sulfonyl chloride in excess KOH, a clear solution is formed, followed by addition of HCl, or white precipitate is formed. Okay, so clear white precipitate. Okay, for aniline. If secondary amine, when addition of benzene sulfonyl chloride in excess NaOH, so a white precipitate is formed. Is followed by HCl, white precipitate will form. So the difference between two is here is clear white precipitate, for secondary is white. Another chemical test, we can use bromine water. When aniline react with bromine water, we can write Br2 aqueous or Br, H2O, and then it will form 2,4,6 tribromoaniline. So this compound will show the observation of white precipitate is formed. While for this secondary amine, right, when react with bromine water, no observable change. So you have to write something negative from here. Okay, contra 1, no white precipitate is formed. Okay, one more chemical test that can differentiate them is by using nitrous acid or the nitric acid test. Aniline, when react, right, will form phenol and nitrogen gas is formed. So for nitrogen gas is formed, right, gas bubble must above 5 degrees Celsius. Because for primary aromatic amine, it's stable if 0 to 5 degrees Celsius, so must above 5 degrees Celsius. Okay, for the secondary amine, right, so for using nitrous acid test, there is no gas bubbles is formed. So you can using here gas bubble above 5 degrees Celsius, here no gas bubble above 5 degrees Celsius. Or another way, here you can write down no yellow oil is formed, and then for secondary amine, yellow oil is formed. So you must always remember for chemical test, one reaction is positive result, another is negative result. Amino acid. Amino acid has amphoteric properties. By using serine below as an example, explain what is meant by amphoteric properties. So you must know what is the definition of amphoteric properties. So based on serine, serine can act as an acid. So it can react with base. And act as base, react with acid. Okay, question B. Write chemical equation to show the amphoteric properties. So the first one, when serine as a base, it reacts with acid. So acid will react with the part of base, means from amine. So it will become NH3Cl. The rest just copy. Okay, serine as an acid, so it will react with base. So base will react with the acid part, which is carboxylic acid. So here will become C-double-bond-O remain, become O negative and A plus. Others part just copy. Okay, question 12 is related with polymer. The structure of Kevlar is shown as below. Write the structure formula for its monomer. Based on here, you know Kevlar actually is polyamide. So you break over here, he is from the amine group, here is from the carboxylic acid group. So the monomer is, so for the amine is NH2, for the carboxylic acid, COH as both ends. Also, you can use C-double-bond-OCl, the acyl chloride. Okay, that's all for today. Thank you.